This is Jeremy Clark of JeremyBytes.com, and we're going to continue our discussion of Lambda expressions and LINQ in C#. In this episode, we're going to decipher the join method. Why does this come up? Well, back in episode 2, we demystified the method signatures that we have for LINQ. So we looked at where, and we saw how it's an extension method on IEnumerable, and it also takes a delegate, a func of t source bool. And as we saw, it's pretty easy to use this method once we understand the different parts. We also looked at the order by method, which has a similar signature. So it is also an extension method on IEnumerable, and it also takes a delegate. And this time, instead of being a func of t source bool, this is a func of t source t key, something that we can use to establish some kind of ordering. And in those examples, we became very comfortable with this, and we saw that it's not very hard once we understand the pieces. But the last few times I've shown this, I've gotten the same question. How do we use the join method? Now, why does this come up? Well, because this is the method signature for join. And who can figure out how to use this? Well, you know what? We're going to figure out how to use this, and what we'll see is that all of the pieces in the join method are exactly the same pieces we've already dealt with. They're just put together a little bit differently. Now, there are two different ways that we can do LINQ. We have the query syntax and the FLUENT syntax. So far, we've just looked at the FLUENT syntax where we dot our extension methods together. But to help us understand how to use the join method, we're actually going to look at it in the query syntax as well. So let's head over to the code. So here we are in Visual Studio, and we'll be looking at a project in the bonus folder. You can get this code from GitHub by just following the links in the video notes. Today we'll be looking at the join syntax project. This is a fairly simple project. It's just a console application, but we do have two different data sets that we can join together. First, we have people. And if we look at our class, we see that this has a single method called getPeople, and this returns an IEnumerable of person objects. And if we look at the contents of this method, we see it just returns a hard-coded collection. Now, the person class itself is pretty simple. It has the same four properties we've been looking at previously: a first name, a last name, a start date, and a rating. But in addition, it also has an ID property. This is a primary key that we can use to link our data together. Now, in addition to our people class, we also have an orders class. And we see this has a single method called getOrders that returns an IEnumerable of order. And if we look at the contents of this, we see it is just a hard-coded collection of order objects. Now, our order class is also pretty simple. We see it has an ID, a customer ID, an order date, and the total amount due. Now, the thing we want to pay attention to here is that customer ID is actually a foreign key. So this links to the ID property of the person object. And this is what we can use to join our two data sets together. Now, in our scenario, I want to create a simple reporting object. And what this will allow me to do is join our data together and put it in a format that we can use in our application. So let's start with the query syntax. For this, I'm going to create a method, and this will be a public static method. And this will return an IEnumerable of dynamic. Now, the reason I'm using dynamic here is because we're actually going to be using an anonymous type. And by using dynamic, it will be easy to get the properties out when we show this in our console application. Now, the report that I want to create is order dates by customer. So I'll create a method called order dates by customer. And then we'll just need to query our data to create this report. So to start off with, I need my data. So I'll start by using the getPeople method that we have on our people object. And we also need our orders. So we'll use the getOrders method that we have on our orders object. So this will get us the data that we can work with. So let's go ahead and create our query. Our output I'm going to call order dates. So now we need to create our query. First, we'll start with our people collection. So I'll say from P in people, and then we want to do the same thing with the orders collection, but we want to join our data together. So we'll say join O in orders, and then we need to tell it how our data relates together. So we'll say on p.id, which is the ID property of our person, equals the customer ID from our orders. So this is just how we set up that relationship between our people and our orders. Now, the last thing we need to do is tell what data we want to return. And for that, we normally use the select statement. But select also lets us do a data transformation, and that's what we'll do here. We don't want to return all of the items from both of our objects. Instead, what we'll do is just return a few of the properties. So I'm going to create a new anonymous type, and we're just going to pull 3 properties out. So I'm going to take the last name from the person, I'm going to take the first name from the person, and I'm also going to take the order date off of the order object. Now what this does is it creates a new type for us that doesn't have a name. And this is the primary reason the var keyword was created. Now what's interesting is if we hover over var, we'll be able to see what comes out of our query. So here we'll see that order dates is an I enumerable of t. And then if we look more closely, we find out that t is tick A. Now tick A is just an internal name that's given to this anonymous type that we created. And if we look down below, we see that tick A is an anonymous type that has 3 properties: a string called last name, a string called first name, and a date time called order date. Now this was all gathered out of this new anonymous type that we created. Since last name is a string and first name is a string, it figured that out. And since order date is a date time, it figures that out as well. And it just gave the name of the properties the same name that we're passing in. So now that we have this data, we can return it. So we'll just say return order dates. And this is why I'm having this object return an IEnumerable of dynamic. You can't directly return an anonymous type because the type itself doesn't have a name that we can work with. But if we return dynamic, then we can pretty much put any type that we want in here. Of course, that also means we don't get strong types on our other side, which we'll see when we start to use this method. So let's go ahead and build and make sure everything's okay. Okay, and we have a successful build. Now let's use this method. And for this, we're going to go to a console application. So what we want to do here is get the results out of that method we just created and display them in our console. So I'll start by creating a variable to hold the output, and we'll call this query order dates, since this is using the query syntax. And for this, we'll just call query order reports dot order dates by customer. And then if we look at the type of this var, it is an IEnumerable of t, and t is dynamic in this case. So it's not an anonymous type, it's actually a dynamic object. So let's go ahead and output this to the screen, and for this we'll just do a for each over the items, and we'll do a console.writeLine. So here's the basics of our write line. So I actually want the order date in a particular format, and then the first name and the last name. And this is where we'll see the downside of using dynamic. So if I say item dot, notice I get no IntelliSense at all. That's because we're using a dynamic object. So I would need to type in order date, assuming that that does actually have an order date property on this dynamic object. And we'll do the same for the first name and the last name. So now let's run our application and see what we get. So now we can see all of the dates that orders were placed by particular customers. Now we don't have any ordering at this point, so what we're getting is just based on how our data was put together. So even though we do have all of the data, it's not very useful at this point. So let's go back and add some sorting. So for this, we'll just go back to our report and we'll just add a new statement. So we'll say order by o.orderDate. So what this will do is sort based on the date of the order. And when we run our application again, now we can see that we're sorted by date. Now the other thing I want to do here is I want to limit the data. So I just want to see the items for December. To do this, we'll just add some parameters to our method. So we'll add a start date and we'll add an end date. And then to use these, we'll just add a where clause to our query. So we'll say where order date is greater than or equal to start date and order date is less than or equal to end date. Now before we run our application, we'll need to modify the code that's calling this. And we can see that we need to add a couple parameters. Well, I happen to have a couple prepared here for us. So we can just add start date and end date as parameters. And we can see those values are December 1st and December 31st respectively. Now if we run our application, we'll see that we do have a filtered and sorted list. So all of our dates are during December 2014. They are sorted by date, and we can see that we have about 11 items here. So we've seen how to build this simple reporting object with the query syntax. Now let's go ahead and use the FLUENT syntax. Now we know the where and order by won't be any problems at all for us because we've already worked with those methods. But the join method is a little bit harder. So let's go ahead and pull up join in help. So here's our method signature for join. Now some of the things that throw people off here is that we have 4 different generic types: TOuter, TInner, TKey, and TResult. In addition to that, we have 5 different parameters, and 3 of those are delegates. So let's just walk through these objects one at a time. If we look at our first parameter, we see it's an IEnumerable of TOuter. So this would be one of our collections. In this case, we'll be dealing with the people object here. So wherever we see TOuter, we can replace that with the type person. Now our second parameter is also an IEnumerable, and we'll see this is IEnumerable of TInner. This will be our orders collection. So anywhere we see TInner, we can replace that in our mind with order. So these first 2 parameters are just the 2 collections that we're joining together. Now to make things more interesting, notice the this keyword on the first parameter. That means we can treat this as an extension method on our first parameter. Again, in our case, we're using our people collection here. So we can say people.join and then fill in the other parameters. And this is really no different than the way we used where and order by in our previous examples. Now our next 2 parameters are key selectors. So notice we have a func of TOuter TKey and a func of TInner TKey. Now remember, TOuter is person and TInner is order. So we have a func of person TKey and a func of order TKey. Now what is TKey? Well, in our order by examples that we saw previously, we saw that TKey was any type that implemented the iComparable interface. Now when we're dealing with joins, this is a little bit different. These need to implement iEquatable, which means we need to be able to tell whether 2 objects are equivalent to each other. And that makes sense when we think about it, because this is how we're setting up that primary key foreign key relationship between our 2 collections. So these 2 parameters let us specify how our data is joined together. Now the last parameter is probably the most confusing because we have a func of TOuter, TInner, TResult. All of our previous funcs just had 2 generic type parameters. This one has 3. Now when we're dealing with func, the last generic type parameter is the return type that we're expecting from this delegate. All the generic types before that are parameters for our delegate. So that means we have a TOuter and a TInner. And again, that's person and order. So in this case, we want a method that takes a person and an order as a parameter and then returns some kind of result. And it turns out this is exactly the same data transformation that we did with our select. So let's go ahead and put all of our pieces together. So we'll go ahead and create a public static method like we did before. This will return an IEnumerable of dynamic, and we'll call this order dates by customer. And we're just using the same method name because we're distinguishing these 2 methods by the static class. So this time we're using FLUENT order reports instead of query order reports. And we'll start out with no parameters to get things going. Now we do still need the people and orders collections, so I'll just copy this from our previous method. And now we get to start using our LINQ methods with the FLUENT syntax. So we do need an output, so we'll say var order dates like we did before. And now we need to start linking our data together. Now, as we noted, join is an extension method, so that means I can go people dot, and I do have join as one of my options. Now, when we look at this, we'll see that Visual Studio has already started doing some of the generic type replacements for us. So notice we have IEnumerable of person. So instead of having TOuter, it has filled in that type because it knows that we're dealing with the person object. Now our first parameter is the IEnumerable of TInner. And again, this will be our orders collection since this is what we want to join to. And now we start getting to our Lambda expressions. Our next 2 parameters are the key selectors. So again, this first one we need a func of person TKey. So what we're going to say is P, which is our person, goes to P.id. So what we're saying here is that our T key will be this ID property, which is an integer, and integer does implement the iEquatable interface. Now the next parameter that we have is a func of tinner T key. Now remember, our tinner in this case is our order. So we can say O for order goes to O dot, and notice that we have all of our properties here, and we can select customer ID. So with these two parameters, what we're saying is that the ID property of our person is the same as the customer ID on our order. So if we go back to our query syntax, this would be the equivalent of our on statement, where we say on p.id equals o.customerID. Now the last parameter we have is our data transformation. So notice we have a func of person tinner tresult. And again, our tinner in this case is our order. So in this case, I need a lambda expression that takes two parameters. That means that I do need parentheses around them. So for the first one, we'll say P for person, and for the second one, we'll say O for orders, and then we'll say goes to, and now what we need to do is return the result that we want for this particular object. And what are we going to do for that? Well, we're going to do exactly the same thing that we did for the select statement when we were using the query syntax. So we'll just create a new anonymous type based on the last name, the first name, and the order date. And if we look at our order dates variable, we'll see this looks exactly the same as when we looked at it with the query syntax. So this is an IEnumerable of T, where T is tick A, an anonymous type, and that anonymous type is a string last name, a string first name, and a date time order date. So we see we get exactly the same results from this as we did when we were using the query syntax. So let's go ahead and return order dates, and then we'll use this in our application. So back in our console application, what we'll do is we'll go ahead and just create a divider so that we have a division between our outputs. So now I'll create a variable called FLUENT order dates, and we'll set this equal to FLUENT order reports and run that method. And then we'll just need to for each over the data like we did before. So I'll just copy and paste this code, and we'll change query order dates to FLUENT order dates, and our output should be the same as we had above. So let's go ahead and run our application to see what we have. So we'll see that our query data did scroll off the screen a little bit, but if we look at the FLUENT report, we see this is in the same state that we had when we first ran the query data. So we do have all of the data, but it's not in date order, and it's not filtered to show a particular date range. So let's go ahead and add those. Now we already know how to do this because that's what we did in part 2 of this series. So let's start by adding some parameters. So we'll have a date time for the start date, and we'll have a date time for the end date. And now we can use these in a where clause. Now, as we saw previously, when we're dealing with the FLUENT syntax in LINQ, we generally dot our methods together. So since join returns an IEnumerable, we can keep going and say .where, and then as a parameter, we do need to return a predicate. Now notice here that the type is tick A, so it's actually expecting our anonymous type as a parameter, and we need to return a true-false value. And if we need a clue, we can see that it tells us exactly what that anonymous type is. So let's go ahead and use this. I'm going to use R, and the reason I'm using R is for result. So this will stand for that anonymous type. Now notice I do get full IntelliSense on this. So since our anonymous type includes a first name, a last name, and an order date, I do get those in my IntelliSense. So we'll say where order date is greater than or equal to start date, and order date is less than or equal to end date. Now we do also want to add sorting, so I'm just going to say .orderBy, and then we'll say R goes to R.orderDate, since we want to sort based on the date. So what we've just done is implement the same functionality with our FLUENT syntax as we had with our query syntax. Now we will need to add some parameters in our application, so we'll just say start date and end date. We'll just use the same variables that we had above. And now if we run our application, what we'll see is we have exactly the same result set for our FLUENT data as we had for our query data. So you might say, well, if we get the same results, what's the difference? Well, that's actually a bigger question. The primary difference between using the query syntax and the FLUENT syntax is that the query syntax is much more limited. So we do have a number of keywords available to us like from, join, where, order by, and select, but there's also a lot of keywords that are not available to us. So one thing we looked at last time was the single or default method. Unfortunately, there's no way to do that with the query syntax. Now we can wrap the results from the query syntax and go ahead and add that single or default to the end if we want, and that may make sense in some situations. But I've gotten so accustomed to using LINQ with the Lambda expressions that I'm almost always using the FLUENT syntax these days, and that gives me access to all of the methods that we have. So let's just review the join syntax one more time. So our first parameter is an IEnumerable of TOuter. This is one of our collections. In our case, we're using a collection of person objects. And since this is an extension method, we can treat the join method as if it were a method on this first parameter. So that's how we can say people.join. Now our second parameter is IEnumerable of TInner, and this is just the other set of data we want to join to. So in our case, it's our orders object, which is an IEnumerable of order. The next two parameters are the key selectors, and this is how we relate our data sets to each other. So our first delegate says we need to take a person as a parameter and return a T key. So we use P for person in our Lambda expression, and in this case we return the ID property, an integer. Then for the inner key selector, we're working with the orders object. So our parameter is of type order, which we use O in our case for our Lambda expression, and we return O.customerID, which is an integer, and it is equal to the ID property of our person object. So again, these are just two Lambda expressions that tell us which properties we use to join our data up. And our last parameter gives us a chance to transform the data. So this takes a person and an order as a parameter in our case, and then we need to return whatever type we want. In our case, we just create an anonymous type. So our Lambda expression has two parameters, a person and an object, which again, we're using P and O to help our brains remember that. And then we're creating a new anonymous type based on the last name, the first name, and the order date. So once we have all of these pieces in place, it's not that hard to understand the join method syntax. So when we walk up to the syntax of the join declaration, it's pretty intimidating. But as we've seen, it's not that hard once we break the pieces down. All we're dealing with is the two sets of data we want to join together, setting the key of how we join them, and then deciding what kind of data we're returning from this particular method. And again, if we're comfortable with func, the built-in delegate types, and Lambda expressions, this gets much, much easier. I love using LINQ methods in my code. There's a lot of functionality that's really easy to use once we understand the basics. So to download the source code and get links to other articles on this same topic, be sure to visit www.JeremyBytes.com. And for a shortcut, just click on the link in the video notes. So thanks for joining me, and I hope this has helped you get a better understanding of Lambda expressions and LINQ. These are very useful technologies in the C# world.